Hi students, now we are discussing the living group. Basicity, nucleophilicity we have done. Now we are going to discuss the living group. Okay, because living group and nucleophilicity basicity we will study in the next mechanism. Living group, why living group is important? Students, see, for any substrate, or you can say that for any nucleophilic substitution reaction, a good nucleophile is must. Correct? If there is a good nucleophile, reaction can go faster. Okay? How you can choose a good nucleophile, good living group? So any nucleophilic substitution reactions, especially good living group is must. Okay? Maybe nucleophile sometimes is not required, especially when you will study that SN1 reactions. Any nucleophile can work, but that living group should be a stronger living group. So why a stronger living group? And how you can choose that living group, better living group? See, students, I have written here one example. Methyl connected with the Y. Why I have written that randomly any substances. Okay, and X is that we have. So X attack from the left side and Y leave the right side. So it means what? While as compared to X, Y is a weaker substances. Therefore, Y can leave the position easily when X will attach. Am I right? That means that act as a good living group, weak base. Correct? So what I am telling you, why when nucleophile is when good living group is released, student, what happen? Attack the X negative from the left side, so Y will leave the positions. This is called nucleofuse. What is called? This is called is nucleofuse. Means Y, because of nucleophile, Y will be fuse. Clear? So that is called nucleofuse. So nucleofuse means what? Any living group which contains the pair of electrons is called nucleofuse. So nucleophile, that is a living group, maybe anions living group or neutral living group. So due to the nucleophile, when the living group leave the positions, that is called nucleofuse. Because of nucleophile, that is a fused, and any living group which contains either the negative charge or pair or simply lone pair. Okay. Now pair of electron is called nucleofuse. We talk about group 17. And students, one more thing is very, very important. When the living group departs the positions, suppose here the living group departs there, that the living group must be most stable. Again I repeat it, the living group is only most stable when the after departs the positions, their stability should be high. Suppose I am talking about A negative and B negative. If I am saying that okay, A negative is the most stable living group, it means what? Okay, just to understand what I am talking about, how you understand, how you can write the order of living group, stability of order of living group, how you will write it. See, students, when we talk about group 17, as you know, group 17 is a stronger acid because of high electronegativity, right? And that means weak base. So HF, HCl, HBr, HI we have. As you know, top to bottom acidity increases. So HF, F minus is a base and I minus is a acid. HI is a acid, HF is a base. Although all are acid, but when we talk about comparison in the same group, then what we can say that HF is a good base and HI is a good acid. Clear? Although both are living group, because we know that group 17 or halogens are a very, very, very good living group. But why the very good living group? Because they are weak base, means a strong acid. I am not saying that a strong acid is a strong living group. No, the criteria is different, students. But one thing you keep in mind, weak base is a good living group. Okay, see here, we have taken that one fluorine, one iodine attached with the propane. Now understand here. Student, both act as a living group, but why iodine I minus is a good living group? I remind you, iodine I minus is also a good nucleophile, as well as I minus is a good living group. Why? There is reason different, here is reason different. See, I negative, when the F and I we talk about I negative means large size. Due to large size means large surface area. Large surface area means negative charge diffuse more. Correct, na? So large surface area means negative charge diffuse more. So when, as you know, when the charge disperse more, stability will comes. More stability is there because charge disperse more. Either you can define the any anions stability by resonance, by inductive effects, correct, by electronegativity, by dipole moments. There are so many methods you can define the stability of any negative charge, but we don't go in that area. Simply we understand here, negative charge or any charge disperse more, the stability is more, because they have large surface area, so charge will be dispersed more. Now spread out more the negative charge. But we talk about the fluoride negative. So Fi minus means fluoride means small size. A small size means the charge will concentrate near the fluoride nucleus. So charge will diffuse very shortly, very near the fluoride ions. Hence, what we can say, fluoride ions is not a good a good living group as compared to I negative, because I negative is larger size, not only more mass but larger size, more surface area, negative charge disperse more. So that's the reason fluorine, chlorine, bromine, iodine is a good living group, because after departs it becomes stable because of more surface area, more negative charge disperse around the iodide nucleus. Correct? Understood why iodine is a good living group? And I hope you understood why iodine is a good nucleophile. The region is different, here is region is different. Okay, now we talk about, see here, so I minus, Br minus, Cl minus, F minus, what happened? So I minus, Br minus, Cl minus, here is the good Lg. I minus, Br minus, Cl minus is good Lg, good living group. F minus, SS minus, Cn minus, OH negative, and OR minus is bad Lg. Done. How I can decide? You can simply there form their conjugate terms and you can understand, but neat strength, simply that's enough. You learn it and you can solve any questions. But here is the very, very important point. Student, sulfuric acid is very good acid, very strong acid. A strong acid, sulfuric acid, and sulfonic acid. I am talking about all sulfuric acid as well as sulfonic acid both. So that means very weak base. It means what? Very little tendency to accept the protons. Correct, na? Because very strong acid means very little tendency to accept the protons. That is a good Lg, good living group. Now I have written here benzene sulfonic acid and p-nitrosulfonate ions. And here is trifluoromethane sulfonate ions, student C, which contains larger electron withdrawing group. Fluoride ions here, correct na? So more electron withdrawing group, it means what? Stronger Lg. Clear? If I put here one more electron withdrawing group, then that will be the more good Lg. So Lg usually more because what I am talking about, here is a negative charge dispersed on the three oxygen atom along with the benzene. Here is also three atoms along with the benzene and nitro group also. So when the more electron withdrawing group, as you know, negative charge stability will be more. So that is the reason here is a trifluoro, even though we can say that trifluoro is a super living group. Correct? Super living group we are saying, but what I am saying, if more electron withdrawing group attach in the benzene ring, that would be a super duper living group. Okay? So I hope you understood how to decide the living group. But simply that's enough. But understand the concept of how to decide the living group. Living group means good, bad, weak base. That means good living group. More electron withdrawing group attach, living capacity increases because the stability of negative charge increases. Why iodine is a better living group. The reason is, what the reason is? Because of more surface area. Okay, so okay, next video will be that SN2 reaction, which help you, but both the lecture you understand perfectly, so that the third lecture when will come, SN2 reaction you understand perfectly. Okay, thank you.